All right, in the previous videos, I showed how the player works, and the player is down here. It's got a launcher, SGR Player, and there's the current version of it. For the first second or so, it's kind of locked up as it makes contact with the audio. And the player is running. It's not recording my voice because it only picks up what's going through the speakers. It's got a number of settings and so forth. This was ported over from Linux. It's a fairly large-scale application. And if you want to make large-scale GTK applications in Windows, this is probably a good place to find things because it does just about everything someone would want to do, I think. There's examples of just about everything in here. That doesn't mean it's easy to pull apart. All right, the second video I went into the Glade file and showed what it looked like. And the Glade file, I'll bring it up again here. Where is it there? And I'll say display. And reminding that I'm using Linux in the background here because the version of Glade on Windows is out of date. Okay, this is the Glade file. The actual Glade file is something close to 5,000 lines of XML. It's, as they say, chunky. There's a bazillion widgets in here. They're all over the place. And it's complicated, as they say. And I went through it and what the basic layout looks like and how things are done in it. And I also cautioned that there are things on top of things here. So some things, if you click on them, you don't get them. Like I just clicked on time to hour, and you notice I didn't get that. It highlighted this panel. Time to hour is, as I recall, it's way down near the bottom. There it is here. And now you see it's highlighted because the order in which they appear in the Glade file determines what is, as far as Glade's concerned, on top when you click. So as far as Glade's concerned, when I click, well, that's something else. This guy, top one, is above time to hour. So in order to get to time to hour, you must make a rather frustrating search to find it. There it is. Sorry, that's just the way things are. But anyway, there's the Glade file. I didn't make any changes. Okay, in the background, what have we got running here? I am in seamless mode. I'm going out of seamless mode now. Let me just make sure OBS is clicking away here. Yes, it is. I'd hate to do this and then get back later and say it's been an hour and it didn't record. This is Linux Mint Mate, Linux Mint with Mate version 20. Uliana or something, I don't know. And it's running in Oracle's VirtualBox. And it's a fully functional version of Linux, but it's running as a program in Windows. And what you're seeing here is their file explorer and so forth. And I'm opened to the directory that contains the software I'm going to use. I use this because there's some code that is only available in Linux. At least as far as I can find. One of which being, of course, Glade. And since you need Glade, and if you're going to modify it, you're going to need Glade. You don't need Windows or you don't need Linux in order to run it. But if you're going to play with it and modify it, you probably do, or something similar. Now I'm using Linux Mint with Mate because I prefer the Mate interface. Others will work, but you'll have to figure them out yourself. Anyway, so that's more or less full screen. I can go to full screen mode. Then it really looks like I'm running Linux, but it's actually a virtual machine. This is non-full screen. So now you can see up here, there's actually, it's a window in as far as Windows is concerned. Go back to full screen, or well, sort of still full screen as far as Windows is concerned. There's another set of keyboard commands that will actually make it take over the whole screen. That was right Control F. Anyway, those are Oracle commands. Nonetheless, you see the, now I go into seamless. So that's right Control L. And what just happened there is this thing, which is running in Linux, is now on the desktop with other things that are running in Windows. This is a Windows command prompt. It's the command prompt you get for the Microsoft Visual C++. It's got all of the, it's got the path set up for all of the, it's one of the ones that gets created when you install Microsoft Visual C++. You can see all of these links here into Visual Studio and so forth, which you need if you're going to compile a program. So this is the window I compile stuff in. It is in the in the directory itself. The directory, I've got it up here. It's in GTK. It's on my desktop. And in GTK, there's one called Player, and that's it. Okay, that's where everything is for me. It's probably, if you're going to do it, it'd be nice if you did something similar so that well, we'd be talking about the same thing if you have a question. So in other words, I created a directory called GTK. I've got other things in it, but the important thing is Player. That's a directory itself, or a folder if you're in the Windows mode. And it's got the things I need, one of which, of course, is player.cpp. And I edit that mainly using Linux, but nonetheless, you could edit it with you know, if I wanted to open it with Notepad or something, I could, and there it is. If you like Notepad, go right ahead. There's nothing wrong with it. It's just not what I'm used to. Okay, so that's where everything is, and you can see the various files here. While I'm up here, well, I've got this up. There's the player.exe. Don't run player.exe because it needs linkages to libraries, and they're not here. They're in sgr.bat down here. That will run player.exe, but it's got the linkages built in. It temporarily modifies path and sets up some other variables too. What things are in here? We've got program list. That's the load. That's what it looks like. It's a list of the media files to be played. It's the default media files, and you see they're all full path names. And I'm leaving it in the distro so you get an example. It won't work on your machine, however. All right, what else are we looking at here as license? These are all where the libraries are stored and things like that that I use. So in other words, you really need to run it from this home directory, from this directory here, which is hopefully you're going to position it somewhat similar to the way I've done it. Anyway, the principal file is player.cpp. I'm not one of those people who breaks things down into 100 different files. I don't find it convenient. I may at some future date, but at the moment, almost everything is in that one file. Not everything, but almost everything. The other files that are included, we have two .h files down here, CSS1 and CSS2. They're CSS code that modify the appearance of the widgets on the screen. So there's two of them there. They get included. And there's pulse.h, which is kind of misnamed. It's the file that creates the visuals for the audio. And when it was originally written, it was written on Linux, and the audio system on Linux is called Pulse. I never changed the name. So down there it's all C code. Well, technically it's all now C++ because I had to magically make it into C++ before I in order to access the just notice the camera's on. I wonder, I don't normally have the camera on, but it turned itself on for some reason. All right, so it's got the graphic code in there. So basically, those are the source files. Oh, clock.h, that produces the clock, obviously. Anything else? Well, there's resource.c, but that's something hideous like this, and it's really very long. It's all numbers. Resource.c is created from resource.xml. I want to edit that. It's an XML file which defines the things that are going to be used by the program. It gathers them together and encrypts them, or not encrypts, but encodes them into resource.c. So resource.c is created from resource.xml. And resource.c is then compiled in, and it gives me access to the icons and everything else. They become part of the program. Otherwise, I'd have to load them as files, which means if you don't went with a distribution, you would have lots of files. Whereas in this case, when I finally get it into a distribution single entity, it will be, all of these icons and so forth will be incorporated into the executable. Anyway, how do you create resource.c? You use this script here. This is a script. It's really going at one line in it. glib compile resources, blah, blah, blah. And target is resource.c, and the input is resource.xml. This you have to run in Linux or something similar to it. You might be able to find it in the WSL Ubuntu. I looked for it. I didn't find it. I didn't spend a lot of time looking for it because I already had it in my virtual machine. So that's what compiles it. You need to run that anytime you change an icon or you modify the glade file. anything that would be incorporated in resource.c, and the list of them there is in resource.xml, you need to run this script in order to create a new resource.c. Until you do it, your compilations are not going to see the change, okay? So those are, I suppose I could put, I can't put it in the bat file because the bat files run, of course, from the Windows side, and the script would not run on the Windows side. All right, so where are we? Backing up. This guy is the program for all intents and purposes. Yeah, we've got some other .h files around here. They are used, they contain source code, but they're secondary, but they're out there. So the main thing we're going to look at is player.cpp. Now, in order to compile it, it's compile.bat, and let me open it for edit, otherwise it'll try to run it. And you can see it's a bunch of library stuff. I mentioned this before, but that's what you compile. And sgr.bat, and I'll open it for edit. And you see, again, a bunch of library stuff, and then eventually it runs it down here. This commented out, start/b, starts it in the background, detaches it. You can use either one. If you're going to make a launcher, you probably want to use this, and then that will minimize the launcher afterwards. But anyway, that's what the code is. You're going to see things like swap files and stuff like that. I don't know who did that. But anyway, it's probably because of, I don't know what that .swap file came from. Doesn't matter. It's not mine. It's something intermediate that's going on. So this is a Microsoft window, the window that's created by the installation of Visual C, and you can compile. So I say compile, because that's a bat file. I don't have to say anything else. And bingo, it compiles. The usual reason for one of the usual reasons for breaking up a file into multiple subfiles is that you don't have to recompile everything every time. But nowadays, machines are so fast, even a 10,000 line program compiles and links virtually instantly. So that reason is gone. Anyway, I like to have everything in one file for the time being. All right, so that's how, and then of course if you run it, it's SGR, and up it comes. It'll throw error messages. There are some things I haven't quite fixed. There are some things it just plain throws error messages. libVLC occasionally gets nasty. Most of the time they don't mean anything. So I wouldn't get all worried about seeing an error message, especially when you quit. It's going to give us GStreamer error. I don't know where that's coming from, but it's an exit error. It doesn't matter. It's not affecting how things work. All right, so I'm going to minimize that. Okay, I'm over here now, and I'm in, this window is actually running in Linux. Okay, and you can see the Linux bar down here, down at the bottom. It's above the Microsoft bar. And, it's got all the usual stuff in it that you would, it's the old GNOME 2.3 interface, which I prefer. But anyway, there you are. I'm going to right click in here, and I'm going to say open in terminal, and it's opened a terminal. I happen to like the black on yellow. I've got my screen cranked way down, so you're probably seeing much brighter colors than I am. My eyesight's not all that good, so I have the brightness cranked down. That creates a higher contrast. I hope it's visual to you. If not, why don't you crank your brightness down? I have an NVIDIA card, so I can, and that's what I use. Of course, NVIDIA is mainly used with Linux anyway, but it runs with Windows naturally. All right, we're here, and we are in Linux. You can see all the code there. Now, what I want to do is I'm using the VI editor. You can use any editor you want. I don't have syntax highlighting on. I hate it. I will not turn it on. If you're partly colorblind, you really don't want syntax highlighting. It makes some of the syntax disappear. So if you want to turn on syntax highlighting, that's your problem, not mine. I'm already editing it someplace. Where am I editing it? Oh, right over here. I'm sorry. Let me get out of this window. I forgot I already opened one. So this is it. I'll go to the top. This is what it looks like. And now let's make it bigger. And we're going to go through and outline where things are in the code, giving you a roadmap of how to find stuff. Basically, the code is set up. There's an initialization section. Then you enter into the GTK routine itself. And after that, it's mainly either timers executing periodically, every second, every 10 times a second, whatever, or it's activity due to the mouse. or some other system activity which creates callback signals. That's how GTK works. Okay, there's a large setup. GTK main. That's a search. If you do what I'm doing right now. That routine right there that's blinking, GTK main. That's where I go down to GTK, and when it returns, the program's over. So it sits in GTK for as long as the program's running. And GTK main is watching all the signals. It's watching your mouse. It's watching your keyboard. It's watching anything it can see. And if it sees you do something for which it has a signal defined, it will execute that. So, for example, if I have a in one of these signals here, they're up. Bring it back up again. Comes in the background. Oh, I didn't mean to do that. All right. So if I click skip, which doesn't do anything because I'm not in program mode. If I click halt, any one of these things, if I click AGC1, that actually shows you something. The others do something, but since I'm not running a program at the moment, you wouldn't see it. But you see the AGC1 and AGC2, they cause checkbox to appear. Those are signals. And so GTK main is sitting there watching for signals. And when it gets a signal that it recognizes, it will call the function that you told it to call if that signal occurs. That's what you're doing with Glade. You're setting up all these widgets, and you're identifying all the signals that each widget will respond to. One of those were those were clicked on such and such clicked when I clicked the buttons. In case of the check marks, it was I think it's toggled on such and such button toggled. I think that was the name of the signal. You can look up the signals. It's not hard. Again, they're in. Let's bring it up in Glade. You can see all the signals. You probably already know this from the other videos, but repetition helps sometimes. All right, so like AGC1, you got to watch out. There's two things here. There's AGC1, and there's also the label that appears in it. The thing that actually has the signal is up above. Now over here, yeah, it's on AGC toggled. So when you click on it, it's going to generate the on AGC toggled. The name of the widget is AGC. The other widget is AGC mod. There's two of them. They're very similar, obviously, on AGC mod toggle. So those are the signals that can happen for that particular button. Okay, I'll just minimize that. I may want to come back to it. So in signals, when you do stuff, signals get generated, and then you find like let's say on AGC. Whoops. On AGC toggle. There it is. That's the function that gets called when you click in the checkbox. It's a toggle button actually, and it calls this function and it asks, is the button active? And if it is or it isn't, you make it active. You set some global parameter saying AGC is off or it's on, and so forth and so on. And they're all over the place. And these things here, to refresh your memory, these are casts. This stuff down here, all caps stuff with a variable name in it. It's casting AGC mod to be a GTK toggle button, because almost everybody is declared to be a GTK widget. And in order to pass certain things down to certain functions, they've got to be of a certain data type. So GTK toggle button set active, that function requires the first argument to be a GTK toggle button. AGC mod actually is a GTK toggle button, but it's been declared as a widget. It's easier just to give the base name and then cast them. So that casts the AGC mod to being a GTK toggle button, which in fact it actually is, so everything works. And it also emits a signal when you do it. Okay, back up to the top. All right, what do we got here? There's the disclaimer for the GPL license. A bunch of include files. Those are going to be anywhere. Some of them are for Microsoft Windows. They wouldn't have been in the Linux version. The IOStream, excuse me, that's, again, technically it's a C++ program. You'll be hard-pressed to find anything that really looks much like C++ in it. But so what? Everything that's in C is basically in C++. subject to some restrictions. There's a bunch of includes. These includes are coming from the libraries that are set up during the compilation. I'm not going to get into them. Reading include files is not a very entertaining thing. These are a bunch of variables and definitions that are used with the audio interface. The audio interface, of course, is Windows. It's different than the audio interface was on Linux, quite a bit different. But there are functions down there that actually capture the audio data, and that is used to set the meters and do the frequency spectrum analysis and so forth and so on. I'm not going to mention them. Other fact, this is them. These are they, whatever. Most of the widgets are declared below. Draw 1 and Draw 2 are the two main audio visualizations. Draw 1 is the one on top, and that's usually the frequency spectrum, although it could be something else at times. And Draw 2 is below, and that's where the meters go. So they're declared up here because I use them. You'll see in the first few seconds. They're used early. Again, this is more audio stuff. I wouldn't, you can fool with it. Go right ahead. Just make a backup first so you can get out of it. It can. There's things you can do in terms of amplification and so forth. Like right here, ramp speed up, ramp speed down there for use for the AGC. The AGC is not a fast operating AGC. It increments by small amounts or decrements by small amount the volume. This is the amount, 0.5. You could increase or decrease the ramp up or ramp down speed on the AGC. It's a fine tuning. It's not a rapid fire real AGC like you would have on a radio or something that immediately responds. This is a slow sweep. Anyway, one thing that we have a lot of here is timers. In the system, there are 3 timers. One timer collects audio data, and it fires 10 times a second. You could increase that or decrease it, but 10 seems to work pretty well. If you decrease it, the visualization will slow down because it's only going to get data 10 times or fewer a second. And if you crank it down to 5 times a second, you'll start to see the meters becoming, the movement's not going to look smooth. It's not technically it's not smooth at 10 per second, but you don't notice it because they jump a lot anyway. If you run it up faster, you're just wasting time. You can fiddle with it. The timer is set up below. This is the function that's called for, this function right here is the audio timer. Well, it's the function called by the timer for the audio. We haven't set up the timers yet. But what does it do? It collects audio data, and then it triggers a draw for the 2 areas that are audio data, and then it returns true, which means please come back here again sometime. Returning true means that the timer should keep running. Returning false means kill the timer. That's standard GTK. So there's a timer here, and there's other timers. So that's the audio timer. It's 10 times a second. You can change it. I wouldn't recommend it. There's another timer that gets called once a second. There's a slideshow aspect too. And the slideshow timer is really simple. It just goes down there and it looks to see if it's time to change the slide. And then there's a main timer. That's once a second. It does a lot of stuff. It checks to see if something's playing. It checks to see if something stopped playing. It updates the time of day. It updates the clock. It does a lot of stuff. It's big. And it's ticking away once a second. So sometimes you see when the thing is running, there'll be a little bit of a delay if you just hit it so that it's a full second before it does whatever it is you were expecting. There, you can notice a little bit of a delay. It's a 1 second delay. I mean, I can go down there, every half second, but it's not worth it. Again, it's a tuning parameter. So there are 3 timers. So what we've got running when your program is running. You have, of course, GTK watching for signals. You got 3 timers going down there, collecting audio, updating the slides, and updating other stuff, time of day and many things like that, what program to play and so forth. You may also have libVLC running. You may be playing a media file. Actually, you're probably playing a media file. That's running independently too, but it runs by itself. You can control it, you can access it, but it runs in its own thread. All right, then you're going to start seeing all over the place. These are all globals, all sorts of global parameters. There's AGC0, AGC, and AGC1. 0 means they're off, 1 means they're on, they're running, and so forth, and things of that nature. The initial main volume level that's set up, and so forth and so on. I'm not going to explain every one of them. You can kind of guess. If you get down into playing with audio, you see these things, and they're explained. All right, what's this? This says that the following is going to be treated as a C program, not C++. Remember, we're technically C++ when we're compiling it. This says that the function gboolean on draw one underscore draw, that's a callback. That's a callback coming. GTK will call that. That is the function GTK calls when it wants to draw the area called draw1 and the area called draw2. GTK doesn't know anything about this C++ stuff. It's going to call it as a C program. So since the program is in this program, it's actually in Pulse. Those two functions, gboolean, blah, blah, blah. I have to declare them to have C linkage. And the G module export is something else that's peculiar to Windows. In Linux, when you load the description of each widget from the builder, it automatically updates the linkage, the symbol table linkage for the for calling programs. That doesn't happen in Windows. For every signal, for every function that's going to be called by GTK, you've got to have a G module export line. You'll see them. There's lots of them. They just have to be there. If they're not there, won't work. So I'm doing these early because I'm going to call it. They get used fairly early. Most of them are down. Oh, here comes Pulse. That's why they're here. Because pulse.h, which is where they're going to be used, they need to be declared before they come in. So pulse.h comes in at this point. And it's a fairly large program on its own, but it's in charge of drawing stuff, audio stuff. All right, we'll see more of those in a minute. These are some functions that weren't in the Microsoft Visual C. They're kind of badly written. I did find some substitutes. Don't ignore them. Then we get a whole lot of definitions. Colors are really popular, and the colors are red, green, blue. Normally it's in a hexadecimal, two digits for... saying that, and here's a 4-digit number for red, green, blue. In some cases, each color, the GTK color, uses 4 hex digits for each color. Most of the colors are 6 digits altogether, with 2 of them for red, 2 of them for green, and 2 of them for blue. It depends on what function they're going to be used with. They're all the same idea. It's how much red, how much green, how much blue. But there's a bunch of them. There's again, these are timer intervals and so forth. Not going to go into each one of them. How many buttons to put on the screen? Don't fool with that. It's not really a variable. It was intended to be one, but that died a long time ago. What my numbers for different media types. I need to add a few here, but MKV is not in here, for example. Anyway, those are my media types. And then more global variables that are used in different functions. And rather than trying to pass them around all the time, it's easier just to make them global. And since it's a big program, there's going to be a lot of them. Like, do you want to see slides? Yes or no? There's a lot of stuff. There's GTK display and GTK clipboard, which are used further down. There's a structure of stuff that's put in there and it's passed around by a pointer. Let's see. Again, another structure, which is the part of the structure. I haven't actually finished this area, but it's a structure that contains information about an item in the program list. Most of it is in these things here. You see these pointer to pointer. It's an array of strings, and the strings, of course, are the names of the files to play. It's allocated. It'll be mallocked further down. That's part of the initialization. This is a large area of things that's passed around via a pointer, SP. It's a structure, and you'll see a lot of stuff that says SP arrow. Like, how many items of media file do we have? It's in here. How many items are in the media file? It's S count, if you can see it. I don't see it. It's up here someplace. Anyway, it's in here. I know that. Well, I think it's in here. Yeah, there it is. Sorry, I didn't say it. Okay, so these things are passed around by means of the pointer to the structure. Windows Audio, that's not used anymore. It was actually used on the Linux side. Then when you were running the Linux thing on Windows in a VirtualBox, you had to clamp down the audio because the interface between Oracle's audio and Windows audio is a little odd. It was louder, in other words. Okay, here we get into function headers. There is a lot of function headers. Okay, these are all C++ programs. These are the function headers. And then we start with the grand list of widgets. I'm sorry, it's just a big long list of widgets. Some of them are probably not even in use anymore. When I mangled it over from Linux, some things died. I've been trying to remove things that are not actually being used, but they're just pointers to widgets. Not everything is pointer to GTK Pixpaf and an error as they're used in, obviously, Pixpaf pictures. Most everything is declared as a widget, and there's lots of them. Oh, adjustments. Those are used with spinners and sliders and so forth, and I'm pretty sure some of these adjustments are out of date too. What else do we got? And I'm just going to scroll down. You can see there's a lot of them, because a lot of them are duplicate. I mean, you've got 12 buttons. Each of the 12 buttons has all sorts of things in it, and so everything's being replicated. Button 1 through button 15, because there's extra buttons besides the original 12. But anyway, all right, here's where CSS1 comes in. It's a collection, it's a function and some declarations for the CSS code. It's being slowly eliminated, but yeah, there's a CSS code that comes in at this point, and some functions. I think just one function. This is the guy here who changes the cursor. If you, under certain types of drag and drop, the cursor changes from an arrow to, on Linux, it changes to a hand. I forget what it changes to on Windows, but it changes the cursor. There's where clock.h comes in. That's the clock program that shows the little clock down on the screen, and it's code and some declarations. Okay, here we go with the GTK modules. Notice they're all extern C. Extern. These are the callbacks coming from GTK, and GTK wants to talk to C linkage programs. So every one of these callbacks and anything else associated with it has to be declared to be a C linkage. So, and you see it starts there, it ends quite a bit further down. So all these functions, like the first one is their void on window main destroy. That's one of your exit routines. That is being declared to be a C linkage program. The Gmodule export is this business about dynamically linked functions. Windows doesn't know about these things because they get set up by the builder. This is, you have to have it. That's all. I don't want to say anything more about it, except any function that's going to be called by GTK has to be declared to be C linkage, and it has to have a Gmodule export on it. And so that's every callback, and you see there's a lot of callbacks. Okay, we're not going to go through them, but some are very repetitive here. These are entry boxes, and there's 15 of them altogether. But I'm not even sure we still got 15. Some of them these maybe have to be pruned. As like I said, there was a lot of mangling coming across from Linux. Don't worry if you can't find something; it may not actually be there. So tried to slowly prune these out, and over time more will be pruned. But as you can see, there's a lot of them, and there's a limit to them over time, number of hours in a day. So those are all the function setups. Boy, that was fun typing in, I'll tell you. You want to go nuts. There's the end of the extern right there. All right, and I wrote main because it was always hard to find in all this jumble. And this is the main program. This is where the main program starts. It gets externals, which actually are technically passed to GTK. You can pass arguments to GTK. There's a whole bunch of stuff. We get a whole bunch of let's do colors. Then we start allocating memory. Like that SP pointer up above with the structure. The structure doesn't exist. So we actually allocate the structure. So we are allocating something of type structure shared memory pointer. The malloc is the allocate. You notice I'm not using new. I told you this really wasn't a C++ program. Size of struct shared memory. So yeah, that's where SP gets created, and then program array gets created, and program data, program played. A lot of these things get mallocked at the beginning. Memory allocate. If you're not into C++, they're basically a new if you're playing C++, but they were. I didn't change them. Well, actually, I did. They were actually technically they were shared memory on the Linux side, which is a more complicated way of doing, but doesn't exist on Windows. And this initializes them. You see SP arrow such and such, that initializes them, and more initialization down here. So without getting into it, command line arguments, I don't know if these are up to date. It's where I look at the argc. It's pretty primitive. There are some functions that do this much better, but this works. And it looks at program list directory. I don't think I'm using that anymore. I guess so. Yeah, program list directory. I don't know what it does, though. I know what it does on Linux. I'm not sure what it does here. Don't play with it. You can set the background color. If you do, make sure you follow the instructions in readme.text or list, whatever it is, text, because they either have to be a color word like red, or they have to be £, followed by 6 hex digits. If it's £, followed by 6 hex digits, it needs to be in quotes. If it's not in quotes, it's your problem, not mine. It ain't gonna work. All right, so most of those you wouldn't use. Only one you'd use probably be the background color. And it's echoing some things out. There's a bunch more initialization. And let's see, more memory allocation. We're allocating the space for each of the allocating space for the entities for the program list files. Let's see. I'm not going to get into these but just allocating stuff and initializing stuff to be empty strings and so forth. Someplace in here I actually load the program. It's in the function called load program. I'm not going to go look for it because I don't find my spec here all that easy. But load program, I don't know where it's called. It's called in here someplace. Maybe it's further down. That's where the actual media files get loaded, or the addresses of the media files. There's where GTK gets initialized, right there. GTK init, you pass down the arguments that were passed to you from main, and you can technically set stuff up. I don't. All right, then we get into builder. This is the glade that was declared up there as of type builder something or other. I forget what its exact declaration is, and it's loading from resource, which means it's coming from that resource.c that got compiled. It's not called that, but it's in there, and you set it up like that, and that's what it sees, and that's where it's loading player.glade. Player is not reading it from a file. I could say GTK builder new from file, but I'm not. I'm saying from resource. Then it's already compiled into the object module of your program or executable. But that's where it gets glade, and that's where it parses it and so forth. Window is the first thing to come out, and its name is window main _ there. Connect signals. Well, the problem is you had to have all those exports before that did anything. I don't know. I don't actually know what connect signals does. It attaches to those things that you've just declared. They have to be declared up above, but this is sketchy what happens here on the Windows side versus the Linux side. On the Linux side, you would not have had those exports. This would have been where everything happened, but it doesn't. And we connect a signal to destroy, and it on window main destroy is called when the destroy signal is invoked. That would be the clicking on the box in the upper right, the X box in the upper right. And what do we get next? Next, we've got all these guys. These are all of those GTK widgets. Some of them aren't, but most of them are GTK widgets. It doesn't matter. You can see the ones that are widgets because they're being cast. GTK builder, I don't know what it's returning, but you cast it to widget. It could be returning another type, but I'm just casting everything to widget just so everything's base widget type. Many of these things aren't widgets. They're scroll bars and they're toggle boxes and entry button boxes and so on. but we just, I just go everything with a widget to start off with, and you cast it back as necessary. And the names over there, of course, are the names that was used in the Glade file. So I'm bringing up the Glade again. So if I've got, what am I on here? I'm an AGC mod, the second one over here, the one down here. AGC mod, that's the ID. And someplace in here, AGC mod is. I'm not going to go look for it. But it's down here somewhere in this mess. Now here's one that gets cast as an adjustment, because adjustments are different. But for every widget that you're going to use, like I say, there could be some in here that are dead, that just haven't been given a proper funeral. Okay, there's an Easter egg in there, and it just got loaded as a result, and that hides it. You're going to have an Easter egg. You can find it if you want. Anyway, then we set up some of the information that's passed around in that widgets structure. All right, a bunch of events. Certain things aren't going to, they're not going to receive the signal unless you tell the system to give it the signal. These are GTK signals. These are mainly scroll bars. I think they're all scroll bars, yeah. And so you've got to set them up so that the widget like H60 or preamp or VLC position will receive a scroll signal. What's a scroll signal? When you move your mouse onto the little thing in the scroll bar, hold down the left button and drag it. That's a scroll signal. So you enable the scroll signals. You got to do it. If you don't do it, it won't work. And I think that, yeah, they're all scroll masks. Oh, there's where the program gets loaded. That's where when the media files get loaded. I know it was around here someplace. And again, we're hiding the Easter egg. I apparently really don't want anyone to see that. I unrep the builder that deallocates some stuff. Background color, if you want to fool with the background. It does a background color parse. So if you gave it a name like red, green, blue, or one of the, the recognized names, I think they were actually called Netscape names. I don't know, get a full table if you look for them. But certain names are recognized verbally. Otherwise, if they're £, red, green, blue with 2 digits for each of them. It parses whatever you pass it. And it will set up color. You notice color is being passed down as an address. Color is a GTK color. It's a color. It's got red, green, and blue in it too. But if the parse doesn't work, you put your own colors in. And those are the default colors. They're defined symbols up above. Okay. And we modify the window and the stack. The stack is all those panels to give it those background colors. And go on, we set up ranges of scroll bars. These would be the scroll bars that scroll back and forth through the program. There's several of them, actually. We set up ranges, what their increment is and what their range is. We get the GTK window for this. Resize it to be that size. You can't make it much smaller. That's actually a tiny bit bigger than it really is. I move it to a certain place on the screen. You can change these numbers and it'll move it to its horizontal and vertical. Turns off some audio things. I don't know what it goes in there and hides some stuff. I'm not sure what it's hiding. May not be hiding anything anymore. This is where it loads title.txt, which is the title appears up in the upper left, which actually gets updated every 5 seconds by default. Show all the windows and hide some stuff program mode, that's automation on, it gets turned off, not visible. What else are we doing up here? We're setting up drag on the tiles, drag and drop on the tiles. This uses a structure. It's kind of messy. This of course is a macro. Instead of typing this 12 times, I have the macro in one place and I invoke the macro 12 times. And those are button numbers or that are going through there. And it's setting up a GTK mask so that it will receive drag and drop signals. That's another GTK mask situation. Not going to get into it. Yeah, but I think I did it on one of the previous videos, how that works. Okay, here we get a bunch of colors again. Let's as to what things are going to appear under what situation. Hiding the Easter egg again. Got to keep that Easter egg hidden. Probably have to go find it now. This sets up a parameter. This initializes something for the Microsoft audio connection. It calls a function that initializes that connection to the audio. A little flaky on how that actually works. I'm new to Microsoft Audio. Microsoft Audio isn't doing it as callbacks. I call it and it gives me data. Whereas in Pulse, it's the other way around. I call Pulse and give it a callback routine. Every time it feels like talking to me, it calls the callback routine. And so it's a different way of doing it. Although, we do use callbacks here. Changes to the clipboard are sent to you as a callback. Whereas you don't call and get the data. You call the system, give it the name of a function, and the system calls that function to provide you with the data. Here's the timers. First timer here is the main timer, and timer seconds is 1. So, so this timer will click every second. And when it clicks, it's going to call the function timer handler. That's the name of the function. It has some, and it will have a parameter to it, and the parameter is widgets. You could have more than one parameter, but that's the main timer. It's called once a second, as long as your program's running. Okay, the next one down here is the picture handler. That's the name of the function. As a matter of fact, on the screen down further below, you see the actual picture handler function. It gets called once a second. It determines whether or not the slide needs to be updated. And you see it's doing a modulo versus slide time. Slide time is 10. So at the moment, anytime the modulo is not 0, return true in order to make sure the timer keeps running. Otherwise, it goes down to display cover. If displaying the cover is turned on, that's the widgets-rand cover. That's saying whether or not it's being enabled to see covers. And then finally is the audio timer, W timer. Why do I call it W timer? This is the Windows, I guess it was. I don't know how I got the name. This is called, this is a slightly different function. It's timeout add, whereas the others are timeout seconds. This one is for units other than whole seconds. And the number is expressed in milliseconds. So it's every 100 milliseconds or 10 times a second. We're calling W timer. It's got no parameter being passed to it. That's the guy that goes down there and collects the audio data 10 times a second. All right. We're getting the GTK display, and we're getting the clipboard. These are global variables. They're being initialized here. There's another way of getting the clipboard, which I've got in here. You'll see stuff commented out, which means there's an alternative way or an older way. I leave them in here until I get sick of them, and then I delete them. But that's another way. As far as I can tell, they're the same. I don't know. Anyway, this gets me the address of the clipboard, and playing with the Microsoft clipboard is different than playing in Linux. But the clipboard I need in order for you to be able to cut and paste stuff. If you want to cut and paste a file name into the program list, I get it through the clipboard. And it's mentioned in the README file. Don't try to copy and paste the media file into the entry boxes. You have to do a copy path. There's a difference here. So I'll go down to big band music, okay? This is my big band music. And if I click the Ipana Troubadours, Ipana was a toothpaste. Anyone remember Ipana toothpaste? From 1930, they were very popular on the radio, I am told, but I'm not quite that old. But the Ipana Troubadours. So if you hit, you could right-click and say copy. Don't do that. It won't work. Whoops, got rid of that. There it is. What you want to do is copy path up here. Copy the path to the selected item. This is different than Linux. In Linux, and there's probably a way around it in Windows, I haven't found it, but don't try to copy the entire media file into the entry box. Here I'll bring this up and I'll show you what I mean. Hopefully this will work, because this is something I just fixed. So back down to broadcast, I'll go down to big band, I'll go down here, and I'll go to my IPANA troubadours. I'll say copy path. Then I'll go over here, and I just clicked, you saw it highlight, and I do a control V, and you can see there's the IPANA troubadours have joined the session. So it's a copy path you need to do. If I tried to copy the file in there, the program will say, why am I getting 1 million bytes of PCM data? And it won't like it. Anyway, hopefully it will just plain reject it, not crash. But all right, the setup is done. GTK main is now called, and when we return, everything's over. All right, so GTK main is running. The timers are clicking away, and you'll see that as soon as it comes up, that wait, because there's a 1 second wait state, or sleep, it's actually called, in order to let the audio connect. And sometimes it connects quick, and other times it doesn't. Sometimes you go to play a file, the first file, it can take a couple of seconds before it starts. I don't know why, because I'm not present there. That's when libVLC is making contact with Windows, and sometimes for reasons unknown, it can be there can be a delay. So that's only the first time. After that, everything seems to work. All right, of course, this is the handler for the pictures. Up above was the handler for the audio, although the initial part, obviously, the program that changes the picture is display cover. But anyway, sometimes when you load a really large picture, it'll cause the audio to freeze, because until it returns, the system is waiting. There is a way around it of getting pictures to be loaded asynchronously. I'll work on that, but sometimes you may see a little pause as it's waiting to load a large. And some of the pictures slides I've got are actually fairly large. There's the timer handler. This is the big giant timer handler. This gets called once a second, and it goes through all sorts of stuff. It's looking to see if the audio's playing, if a file is playing, if it's not playing, whether we're in a pause mode, whether we're going to pause at end. It just checks a lot of things. It changes colors of things. It checks the audio adjust. It actually calls down, that's way at the end. That's a big program that just does the AGC. It updates the clocks. That's it down there. It's a big program, and like I say, it gets called once a second to decide to do different things. Most of the time, it doesn't do anything, but it updates your screen to indicate what's going on, and it also updates the time of day on the tiles. But they only get updated, I think, once every 5 seconds. It's not urgent that they be updated frequently. You can change that. There's the window destroy. And then we start into a whole bunch of service functions. Obviously, button color changes the color of a button when you call it. And the button here would be a tile. And depending upon what state it's in, then there's the display program buttons. This probably needs to be rewritten, but you can see there's they're actually tiles. Tiles, mainly this is working with tiles. Here is again another macro. I had a lot more macros in here, but I've gotten rid of them. I've just linearized them. It's easier to read. Macros are hard to read. The macro preprocessing language in C is crappy. These are there's a situation that numbering is not sequential. You notice it's going 7, 0, 8, 1, 9, 2, 10, 3. Then eventually it's 2, 8. The second number there is going up from 0 to 11 consecutively. The first number isn't. When I originally wrote this thing, it had different buttons on them, and they originally had different numbers, and they were in different places. And now they've coalesced into this location, and the numbers are out of order. There's tables to show you what the numbers are, but don't be surprised if things are in places they don't appear to be numerically correct. I mean, who needs numerically correct numbers? Anyway, I go over to the edit panel here. I think it shows up here. That's entry 7. The second one is entry 8, 9, 10, 11. Looks good. 12. Why it started with 7, who knows? 13, 14, 2, 3, 4, 15. Okay, so it's they're not, and you see those are the same numbers on the screen here. Sorry, someday I'll go in and fix them, but it's like pulling one thread, the whole thing will come undone. It's just because they're all over the place, and finding all the places where these numbers are used would be not going to be fun. But they're there, don't worry about them. Well, you will worry about them when you find them. These are checkboxes. A lot of this is very redundant code. That's why I was using so many macros. These are all basically service functions near the top. I'm not going to go through them because it depends on what you're trying to do. Okay, then we start getting the actual callbacks here, like the pause program. If you click the pause button on pause video toggled, it was originally a video was used, but that's just pause anything. That's the name of the pause button. If you look on Glade again, you can backtrack through Glade to see these things. Here it is, pause player, it's caused. And actually, you see over here, it's actually pause video. But on the screen, it says pause player. Why not be confusing? Let's see. And it's calling a function which causes the VLC player to pause or unpause and so forth. Show slides button. You see, these are all of we're getting a lot of callbacks here. And there's lots of them. That's a different pause. Pause. No, that's the one. There's a pause at end and there's a pause current, but there's a lot of them. A lot of these on blah blah blah, and then you'll find areas where there's just huge numbers in them. All effectively the same. Here's our odd numbering again, just. These were macros, but the macros were so difficult to read, I unraveled them and just didn't matter. I mean, the macro code generated the same number of lines. So it doesn't actually, it just changes the source code that I'm looking at. It doesn't change the source code that the compiler is looking at. But you'll see a lot of this very redundant looking code. Oh, here's a map of entry 7 is really row 1 and so forth as we go down here. There is a map in here, if you can find it. Anyway, there's just more and more and more of these. So essentially speaking, if you want to start ripping something off, and you want, well, shall we say, borrow, you find what it is you want. And let me go back to tiles. Like the scroll bars are always fun. Scroll bar, some of these scroll bars are connected with other scroll bars. This scroll bar here is connected with the scroll bar on the edit window. This here and this guy over here are really the same scroll bar. But this one down here is independent. It's called search scroll, okay? And so if you wanted to find it, you'd go to the top and say search for search scroll. And there's where it's declared, and initially it gets a null. I don't know why I was nulling it. There's where its handler, I guess it's got two handlers, on search scroll value changed, on search scroll event. It's got an event and it's got a value change. There's where it comes back from the GTK builder. And there's where its range is set up between 0 and SP count and S count. S count's the total number of media files, which is its range. Its increments are by 1. That could be by different numbers. When you scroll it, how many clicks is it going to go through? It's set to go by 1. You can make it go by 4. It's actually that scroll bar applies to a lower panel, a lower tray, which has 4 tiles in it. But it's set by 1. And let's see, it initializes it to xbegin. What are you going to see on this? Where is it initialized to? It's initialized to the beginning. Xbegin is the first entry in the lower tile, lower tray, as I call it. Let's see. Now we're getting into. This is in the timer. I guess it's in a first time. It is actually okay. It's again setting the range. I guess that's after a program change or something. If you reload the program, you'd have to change all the ranges again. So on search scroll value changed, and it receives a range. And what I do is I get the value. They come back as double precision floating point, and I promptly make it an integer because it is an integer to me. And I check to see if it's above the limit, which is the S count minus 4, because it's only in which case I decrement it. I set xbegin to what this is where you want to put the scroll. So you've dragged it across, and now I just got the number back telling me where to put it. And I reset X begin. That gives you the that sets up the lower tray as to what will be seen in the leftmost tile. And then you hit display program buttons, which paints the screen. Then there's a search scroll event handler. Let's see what it is. Oh, the direction of this is the actual moving of the mouse roller. Okay, and I'm not going to get into it because, but it's here. So that should be. There's the event. This is a service function. It's not a call. Here is the actual call here on search scroll. Here it is. This one down here. On search scroll event. Okay, that's what gets called, but it calls that service function up above. Yeah, I think that service function is only called once now. It was called multiple times before. I'm not sure. But anyway, that's where it is, and it goes on and on and on and on. This is turning off and on the tooltips. Tooltips are off by default. You can turn them on or turn them off. Tooltips can be annoying if you already know it's there. You get all these pop-ups. Well, it has the ability to turn off the tooltips, but you know, bazillions of lines of code. And then down the bottom, you've got audio code down here, and so forth and so on, where it captures where it initializes the audio and captures the devices, and someplace down here. This is at the bottom. Audio adjust. Oh, that's the AGC. But anyway, up above, where does it actually calculate the audio? I know I'm going too fast, but okay. Audio is where the timer calls audio. And the audio is what captures the audio PCM data from Windows, okay? It copies the data, and get data as actually the function that does it down here. It's a subroutine. And you'll notice that this is the place where you actually see, yeah, there's C++. Okay, there's the C++ line. That comes from Microsoft. That's why we're in C++. Because the audio interface is that way. And the actual program that gets the data is get data. And basically it gets 400 observations. It stores them. It does some things. It modifies this in kind of a amplification here, because they're too tiny to be used with the rest of the system. It's jury-rigged because it was originally tuned for pulse. But I have to adjust numbers coming in so that they're consistent. Someplace they had to be adjusted, either on the pulse side or this side. So that's actually amplifying the numbers. So that is a general layout. I know it's been confusing, but you know, that's what everything is. There's a big section of initialization. It's like 2,200 lines of initializations before you call GTK main. And then it's either a signal because you did something with your mouse or keyboard, or it's a timer that's clicking along. And you can see this, I bring it up here again, running. Whoops, the initial second there, you really shouldn't be playing with it. But every one of these clock ticks here, that's actually the timer updating the clock. And the clock code, clock.h, just shows a clock face, but you have to pass it, or it has to know the time. And so every second it's updating. If I go to tiles, you see the tiles are here updating with the time, because no program is playing. Means this file is going to play at 14:55, 34, 35. That's the time it can play, which is the current time. So you've got these clocks going on. That's the timer on that surface. Over on slides, I don't have any slides, but that's a different timer. And then there's the audio timer, which isn't doing anything at the moment because I'm not playing any audio. And so it's just sitting there idle. All right, I hope that gave an indication of how you can pull that file apart. It is a fairly large GTK application, and it certainly runs on Windows. There's a VU meter there. It's also on my website, which is just a standalone VU meter. I put little tiny buttons down here I don't know if you can see the blue against blue, but that makes it just a panel. It drops the decorations. And then there's some of the buttons that change it from volume levels and so on. Unless it's actually working, you won't see what those are doing. But that's a smaller application. It's basically just the audio code. All right. I hope that wasn't too much.